Okay, we saved the best for last in terms of antiderivative of powers. We kind of put everything together. So let's read this. We have the antiderivative of the cube root of x minus x squared plus 7 all over x. And guess what? I forgot my dx. And I'm going to do that with respect to x. Again, if you took the antiderivative with respect to y, it'd be a completely different thing. So we're not going to talk about that right now. It just means with respect to x, just like taking the derivative with respect to x. So without further ado, we need to convert this to power form. In order to do that, first of all, let's change this cube root of x to x to the 1/3. Looks more like a power. The second thing we're going to do is take each of these expressions and divide by x. It makes it a lot easier, and it changes it from a rational function to a power function. So we'll get x to the 3rd over x to the 1st minus x squared over x plus 7 over x. Now 1/3 minus 1 is negative 2/3, and we're dividing like bases. X squared over x to the 1st is x to the 1st, and 7 over x we can rewrite as 7x to the negative 1. So we've now got it in a form that's more like 3 different powers. Now we can use just the reverse power rule and figure out our answer. So antiderivative of x to the negative 2/3 minus antiderivative of x to the 1st plus antiderivative of 7x to the negative 1. We're using the reverse power rule. We're using subtraction addition rules. We're using constant multiple rule, everything. Now, we haven't learned this yet, but okay, so I want you right now to let's just focus on the first two. We'll talk about the third one. Antiderivative of x to the negative 2/3, you would add 1 and to that original exponent and divide by that number. So we'll talk about that in a second. And add 1 to this exponent, and that's x squared. You divide by that number. So let's try to take the antiderivative of x to the negative 1. You would add 1 to that exponent, right? And you would divide by that. So that's x to the 0 over 0. Whoops. That is undefined. Okay. As it turns out, the antiderivative of x to the negative 1, which is the same thing as 1 over x, is natural log of x. Now, we actually already knew that. The reason we already knew that is we knew that the derivative of natural log of x is equal to 1 over x, which is the same as x to the negative, which is the same as x to the negative 1. So if you're taking the antiderivative of x to the negative 1, it's the same as the antiderivative of 1 over x, which equals ln of x. So it makes sense, right? It's just the reverse rule. So x to the negative 1 is the exception. It is a power function, but it has a special antiderivative, namely natural log of x. So keep that in mind. So that's why that becomes natural log of x, and a lot of times we write natural log of absolute value of x just because you can't take the natural log of a negative number. And again, because the constant multiple rule, basically you can just pull the 7 out, take the antiderivative of that, and then include 7 in your answer. And just think about it. If you took the derivative of this, it'd be 7 times 1 over x, which is 7x to the negative 1. So now from here, we're just going to simplify this, and this. Negative 2/3 plus 1 is 1/3, so it'll be x to the 1/3 divided by 1/3. And that was just me showing that. Okay, so x to the 1/3 divided by 1/3 minus 1/2 x squared plus 7 natural log of absolute value of x. By basically dividing by 1/3 is the same as multiplying by its reciprocal 3, so your answer final is 3x to the 1/3 minus 1/2 x squared plus 7 natural log of absolute value of x plus c. That is a lot to say. Let's check our work by taking the derivative of all this and seeing what we get. So the derivative of 3x to the 1/3, we would move the 1/3 down, subtract 1 from the exponents to get negative 2/3. That's going to become 1, as we've seen time and time again when we do the reverse derivative, or the reverse antiderivative, I guess you could say. So we get, that's negatives are going to become positives. It's going to be 1 over x to the 2/3. Derivative of 1/2 x squared, move the 2 out, subtract 1 from that, so it's minus 1x, which is minus x. And then the derivative of natural log of absolute value of x is just 1 over x. And then so it becomes 7 times 1 over x, which is 7 over x. So we get 1 over x to the 2/3 minus x plus 7 over x. We need to convert this, however, back to the way we had it. So in order to do that, we'd have to multiply the top and bottom by x to get an x on the bottom, basically, to create our original function back. So now everything on the top gets multiplied by x, so that goes away, and there's an x here. This will convert x over x to the 2/3 will convert to x to the 1/3, because it'd be x to the first. Anyway, x to the 1/3, and then we would convert that back to the cube root of x, and guess what? That was the original function that they gave us. And so that confirms that our antiderivative, our actual answer, is this. So that's our antiderivative, and that was the original function that we were given. Okay, so just to re-clarify, the derivative of this, which is our answer, is the function they gave us. And that's the essence of antiderivative. If you have any other questions about antiderivatives of power functions, let me know.